Here we're given a graph of a transformed function and asked to write its function. So the first thing that we want to identify is which basic function that we are working with. We can see from the U-shaped graph that our basic function, or the toolkit function that we're working with here, would be our quadratic function or our x squared function. So remember what our basic x squared function looks like. Normally it would have a vertex at 0, 0, going through the points 1, 1, and 2, 4. And then we are symmetric about the y-axis. So at least picture mentally our basic parabola, and then we want to think about how things have changed. So instead of having a vertex at the point 0, 0, now our vertex is at the point -1, 1. So as we start to think about plugging in some of that information, we can use that as we write our function. So let's call our new function g of x. I'm going to leave a value of a out in front for my leading coefficient because I know for certain there has been a reflection. So a is going to be something negative, and it also appears that there's been some kind of compression of our graph as well, as it's changed which points it's going through a little bit from our toolkit function. We can find all of that at once by just leaving a leading coefficient of a out in front. Since our vertex has moved 1 unit to the left from our toolkit function, I can represent this by changing the inside of my function with a +1. So remember, on the inside it moves kind of opposite of what we would expect. A plus moves to the left and a minus moves to the right. We also see that our function has moved up 1 unit, so in the vertical direction I'm going to write that as a +1 on the outside as well. To find our value of a, we need to find some point on the graph. We can use any point that has some nice integer values. So I'm going to go ahead and use this point right here. Thinking of this as an ordered pair, this is the point -3, -1. So I'm going to plug that into my function and solve for a. So here we have g of -3 is equal to a times -3 plus 1 squared plus 1 should be equal to -1. So notice that we're plugging in -3 in place of the x, and we're setting it equal to -1. So now let's simplify. -3 plus 1, we have -2 squared plus 1 equals -1. -2 squared is 4, so we have 4a plus 1 equals -1. Subtracting 1, we have 4a is equal to -2. And dividing, a is equal to -2/4, which we could simplify to -1/2. So putting this all together, our function g of x would be -1/2 times x plus 1 squared plus 1. So graphically, there have been 4 transformations that have happened to our basic toolkit function for our quadratic function. The +1 on the inside is because this has moved 1 unit to the left. The +1 on the outside is because this has been shifted up 1 unit. The negative in front has caused a vertical reflection, and the 1/2 out in front has caused a vertical compression or a shrinking of our points closer to the x-axis.